let's review the graph of sine real quick. Okay, reviewing the graph of sine, what can you tell me about this?
Starts at the origin.
Starts at the origin, right?
Where sine
How high does it go?
is.
One. It goes up to 1, and it goes down to negative 1.
Yeah.
Okay, remember the period is what? 2 pi? Period here is negative 2 pi. And so remember we break those into fourths. And then remember what I do is I go ahead and graph the inverse, or graph sine. And so this is what sine looks like. Okay. So there you go. And so now what we're going to do is we're going to talk about the inverse. Now if you remember back in chapter 1 when we learned about inverses, in order for it to have an inverse it had to pass the horizontal line test. This fails the horizontal line test miserably. Because remember, in order for it to pass the horizontal line test, if I move a horizontal line throughout here, it can only touch the graph at one specific point. So if you notice, any horizontal line here is going to touch the graph at numerous points, an infinite number. And so what we would do then, remember, is we would restrict the domain. And we would say, okay, only look at these values. Only look at this part of the graph. So let's say I restrict the domain right here, and I start here. Where would I stop restricting the domain so that it would pass the horizontal line test?
Positive one on top.
Yeah, positive one right here. And so this is how I'm going to graph the inverse. I'm only going to look at that value, and that value is from negative pi over 2 to positive pi over 2. And I'm going to restrict it to that area. And so when I graph the inverse, okay, I'm going to restrict the sine function, and that's what's illustrated here. Now let's go ahead and look at the domain here of this first. The domain here of the first one will be from negative pi over 2 to positive pi over 2. Now notice I am including those points. The range, what's the range of this graph here? Negative 1 to positive 1. Now whenever I graph the inverse, I flip those, remember? And so the domain of y equals inverse sine of x will be negative 1 to positive 1. What's the range going to be?
Negative pi over 2, pi over 2.
Okay, negative pi over 2 to positive pi over 2. Now we need to file this fact right here to memory. We need to file this away to memory because we're going to use this a little later. Okay, so now I need to graph this. So it says that my domain is from negative 1 to positive 1. So what that means, here's my x. So I've got negative 1 here, and I've got positive 1 right here. My y is from negative 1/2 pi to 1/2 pi. So now, you can even do this on your calculator. I will need to find what the value is at negative 1. So on your calculator, what is the inverse sine of negative 1? Negative 90. What's negative 90 equivalent to? Negative pi over 2. I want you to do the same thing with 0. What is the inverse sine of 0? 0. Do the same thing with 1. What's the inverse sine of 1? 90. So that's what our dots look like. Here is what the graph is going to look like. That is the graph of the inverse sine of x. Okay, domain, negative 1 to 1. Range, negative pi over 2 to positive pi over 2. So basically, when you think about this, I'm taking the inverse sine of a number between negative 1 and positive 1. And I'm getting an answer from negative pi over 2 to positive pi over 2. So I'm getting an angle as my answer. Okay, let's look at cosine. Cosine, we're going to restrict the domain again. And so if you look, that's what I've restricted the domain to. What's the domain here? 0 to pi. What's the range? Negative 1 to 1. So once again, when I graph the inverse, those flip. So my domain will be from negative 1 to 1. What's my range going to be from?
0 to pi.
0 to pi. Once again, you need to file 0 to pi away to memory. And we're going to come back and revisit that later. So really, negative 1 to 1, And then I'm going to go from 0 to pi. So now I'm going to plug in -1 first. -1, what do we get? What? -1? You get 180? Okay. What do you get at 0? 90. What do you get at 1? 0. Okay. There you go. That's what your graph looks like. Now notice, all we're doing to graph these is we're just using -1, 0, +1. Now tangent, on the other hand, is a different graph. Tangent, the domain, what's the domain going to be here? -pi/2. Yep. Now notice I'm not going to include -pi/2 because what happens at pi/2? What do we have? What are those called? Asymptotes. What's the range going to be? -infinity to +infinity. Good job. So then now if I flip-flop those, the domain of tangent will be -infinity to +infinity, and the range is going to be from -pi/2 to +pi/2. So what that means is that the whole x-axis can be used, but I'm only going to go as low as -pi/2, and I'm only going to go as high as +pi/2. Now what ends up happening at pi/2 and -pi/2 is I end up having horizontal asymptotes. Notice the asymptotes were vertical in tangent, so in inverse tangent they're going to be horizontal. So now the question is, how does it go? So let's start. Let's pick a value. Let's pick -1. -1 was a good number for us to plug in. What's the inverse tangent of -1? -45. So that means the graph's going to be like down here. What's the inverse tangent of 0? Inverse tangent of 0? 0. What's the inverse tangent of 1? 45. So now the graph is actually going to look something like this. Okay. So, another thing to keep in mind, this value right here, -pi/2 to +pi/2. So now what we're going to do is we're going to evaluate, we're going to evaluate and find the exact value of this expression. Now if you remember, when I found exact values with sine, it was sine of like 30 equals 1/2. Now what I'm going to be doing is taking the inverse sine, so I'm going to be finding out what angle gives me a sine of 1/2. So this is what you're going to do. This is how we're going to go through this. Just a little tidbit to file away to memory. Inverse sine. You are in quadrants 1 and 4. Inverse cosine. You are in quadrants 1 and 2. Inverse tangent. You are in quadrants 1 and 4. Okay, file those away. Now, where I'm getting 1 and 4, 1 and 2, 1 and 4, that is from the range. If you remember, the range of sine was -pi/2 to +pi/2. That is quadrants 1 and 4. Cosine, the inverse cosine range was 0 to 180. That is in quadrants 1 and 2. Now, come test time, I'm not going to expect you to memorize this. I'm going to let you have a note card, and we'll talk more about that next week. Okay, but this is something that probably would be good to write down. So first of all, I'm going to draw a triangle, because if you remember, the triangles kind of helped us. And so inverse sine right away, I know I am in quadrants 1 and 4 only. So that means I can automatically throw out these two. Now, in quadrants 1 and 4, I have two options. Okay, I know that sine is positive in quadrant 1, it's negative in quadrant 4. This here is a Positive. So what quadrant is my triangle going to be? 1. So what I'm going to do now is draw a triangle in here. Just draw a triangle, doesn't have to be any certain size. Sine is defined as opposite over hypotenuse, so I'm going to write it this way. Opposite over hypotenuse. And so now I need to figure out what angle gives me that. So what angle is opposite a side of 1/2? What is our special angle that is opposite a side of 1/2? 30, yep. Now, we can't answer in terms of degrees. I need to answer in terms of radians. So what does 30 convert to? Pi over what?
No.
6. Easy way to remember. Okay, you have 180, which is 18. 18 divided by 3 is 6. So that's kind of a little trick you can do. Let's look at another one. Arc sine, same thing as inverse sine, it's just written this way without the negative, 1. And this is the inverse, or arc sine of root 2 over 2. First thing I'm going to do, I know the inverse sine is in what? 2 quadrants. 1 and 4. So automatically I can throw 2 and 3 out of the mix. Of 1 and 4, where is sine sine positive? 1. So I'm going to go ahead and do this. Okay. Sine is root 2 over 2 over 1. I'm always going to put it over 1 just because that's how I remember the sides in my triangle. And I know that what type of angle gives me a sine of root 2 over 2? 45. I need to convert that to pi. That is pi over 4. Questions? Inverse sine of 3. So once again, where does sine live? Our inverse sine live? 1 and 4. What quadrant will I be in? 1. So I can write this as 3 over 1. So what angle gives me that?
I don't understand. Go ahead,
What?
it's undefined.
Ah, or it's not undefined, it is. It doesn't exist, that's right. So in this case, we're going to put, now for those of you wondering what was being said, you probably didn't pick up on this. The observation was that this number here is bigger than the hypotenuse, which means you can't have a triangle. Now, let's look at why that works too. If you remember when I looked back at my domain and range, remember I had domain of inverse sine. So back on slide 2, I had y equals inverse sine of x. My domain, if you remember, was -1 to 1. My range was from negative pi over 2 to pi over 2. Remember domain right here? That is the only values that work for x. You can only use between -1 and +1. This is 3. That doesn't work. You can only use numbers between 1 and -1. If you have anything else, it's no solution. So let's go ahead and look at this one, inverse cosine. So inverse cosine. Inverse cosine, what 2 quads? 1 and 2. So this one's a little different. So we're looking at these 2. Okay, inverse cosine then, quadrant 1 and 2. What quadrant will my triangle be in? Why 1? It's positive, good job. So cosine, remember, is adjacent, so we're talking about this side right here over 1. What type of angle? 45, nice job, which gives me an answer of pi over 4. Excellent. You guys are getting the hang of it. Okay, let's look at another one. The more we do, the better it becomes, honestly. Oh, okay. What quadrant?
2, 3, 1.
1 and 2. Okay, Okay, now we got a problem.
No, we don't.
Does anybody know what the problem is?
Negative number.
It's negative, so it would be in quadrant 2. Does it, anybody know the other problem? If I write this as a fraction, it's negative 1 over 1. So once again, your sides and hypotenuse can't exist. This is what I will tell you. Whenever you get something that's negative 1 or 0, and you're dealing with sine and cosine, you need to remember the points that we started with very first. Now, these are points on the unit circle. This point here has a coordinate of 1, 0. This point here has a coordinate of 0, 1. This point here has a coordinate of negative 1, 0. Now, if we go back and remember sine and cosine, sine went with what coordinate? Do you remember? Sine went with y. Cosine goes with x. So what that's saying is that at 0, cosine is 1. So this is cosine. At 90, cosine is 0. At 180, cosine is negative 1. So which of those three would answer that? The third one, 180. So your answer would be 180 degrees or pi. Now the question is, how do you know when you draw a triangle and when you don't? This is pretty easy because when you put it over 1, you know you can't draw a triangle where the adjacent side of a triangle and the hypotenuse side are the same. The only way you can do this is if it's on the axes. All right, arctan of 0,
So what's the answer to that one?
180 or pi. So arctan of 0. So first of all, where does arctangent live? 1 and 4. Now we've got kind of one of those instances again. Because now how do you draw a triangle with a side length of 0? So what are we going to look at? Points. Now here's the beauty of arctangent. Negative pi halves and positive pi halves were not included if you remember. Remember we used open parentheses? So the only option is this one right here, and we're going to just see if it works. Okay, is the arctangent. So if I look at this value right here, do I get a tangent value of 0? Yeah. Okay. And so as a result, your answer here is 0. And that's the only way you can write it. You can't write it as 0 pi. It's just going to be 0. Now the zeros and the ones are kind of tough to understand. I understand that. And it's going to take you a while to get those. Okay. Let's look at this one. This is our very last 2 problems. Very last 2. Very last 2 problems. Now what do we know about a function and its inverse? So like if I had y plus 5 and then I chose to subtract 5. They both undo each other, right? Well, this is a function and its inverse. Now the only issue we have is that if they undo each other, I get 2 pi over 3, right? But arcsine isn't in 2 pi over 3, right? Because arcsine is only in what, 2 quadrants? Arcsine is only here and here. So what I need to do is come up with a triangle that has the exact same values, but it's in these 2 quadrants, or one of the 2 quadrants. And so when I think about that, 2 pi over 3, that is a 60-degree angle, right? And so if I were over here at 2 pi over 3, would you agree that this triangle over here would have the same value for sine? It'd have the same height? Okay, so this value here will be pi over 3, or 60 degrees. And so that is going to be your answer. That's kind of a shortcut way. I could go into the long depth explanation, but it's going to take us way longer, and I think you'll get what you need from this. Okay, the next one actually I think is a little easier. Arctangent of tangent of pi over 2. think about what we just talked about. What do you think your answer is gonna be? Last one. What do you think your answer is gonna be? Inverse tangent and tangent, what do? They cancel each other out, right? So then that leaves me with pi over 2. But let's think back to arctangent. Arctangent, could I get pi over 2 from arctangent? No, because what happened there in the graph? Remember, it has an asymptote. So as a result, I can't get this. And so this is actually a no solution. Those are probably some of the tougher ones to understand. You've only got a few on your homework. Do the best you can. We will come back and answer any questions you have on Monday. Okay. We're not going to spend an overabundance of time on this section. I just want you to understand the basics of finding the inverses. And so this is what I need you to do. It's not a whole lot of problems, and I will be honest with you. If you work now, even in these last 15 minutes, you can get probably close to the whole thing done. We had some people 4th hour that did that. So